You have fallen asleep more than 10,000 times. If you're in your 30s, that number is probably conservative. And yet you cannot describe what it actually feels like. Not a single time. You can describe the moment before it, the thoughts drifting, the body loosening, the sounds of the room becoming somehow less real. But the crossing itself? Gone. Every single night, without exception, that moment disappears before you can catch it. Most people assume this is just how sleep works and never think much further than that. But once you start pulling at that thread, something genuinely strange unravels. Because the reason you can't remember falling asleep is not random. It's not a glitch. It's a precise, deliberate biological mechanism your brain runs every single night, dismantling your own awareness piece by piece in a sequence that's been refined over millions of years of evolution. If that already has you leaning in, hit subscribe and leave a like. And at the end, drop a comment with this. Do you remember your dreams more often than you remember falling asleep? Read every response that comes in. So the first question worth asking is the one most people skip entirely. What is sleep exactly at the level of what your brain is physically doing? The popular image is a shutdown, a phone dropping to 0%, the screen going dark, everything going quiet. But that image is completely wrong, and the reality is far more interesting. Your brain has no off switch. Even during the deepest stages of sleep, it burns almost as much energy as when you're sitting up making coffee. What sleep actually looks like from inside the brain is less like a machine powering down and more like a highly coordinated shift change at a hospital. Different systems hand off responsibility in a specific sequence. The department that was running your conscious experience during the day quietly packs up and leaves. Another department comes in, turns down the lights, and starts a completely different kind of work. The chemical side of this process runs on something called adenosine. Every hour you spend awake and active, your brain produces adenosine as a byproduct of burning energy. It accumulates steadily, hour after hour, and as it builds up, it starts suppressing the systems that were keeping you alert. That's the biological weight behind the word tired. And that's also, by the way, exactly why caffeine works the way it does. It doesn't give you energy. It doesn't replace sleep. It simply blocks adenosine from binding to its receptors, tricking your brain into not reading the signal that the debt has been accumulating. Send this to someone who refuses to believe that coffee is lying to them every morning. And stay here, because what comes next is where this gets genuinely strange. The second question gets closer to the real mystery. If the brain is still running, still active, still burning energy all through the night, why does memory fail at that exact moment? Why can't you record the crossing? The answer lives inside a small but extraordinarily powerful structure called the thalamus. Think of it as the strictest gatekeeper in the entire nervous system. When you're awake, every signal from the outside world has to pass through the thalamus before it earns access to the cortex, the part of the brain responsible for conscious experience. The sound of traffic, the weight of your blanket, the smell coming in through the window, all of it clears through that gatekeeper before it becomes something you're actually aware of. When sleep pressure hits a certain threshold, the thalamus closes, not gradually, not politely. It cuts the flow of incoming sensory information to the cortex in a way that's close to abrupt. Your vision and touch go first. Sound holds on the longest of all the senses, which is why you can still sometimes catch a voice or an alarm even after everything else has gone quiet. But eventually the cortex finds itself cut off from input entirely, and a memory requires raw material to form from. Without incoming sensory data, the hippocampus, the brain's recording system, has nothing left to encode. The camera runs out of footage before the event is over. But here's where a third question appears, and it's the one that almost everybody has experienced directly without ever quite understanding it. If the thalamus already closed the door, the cortex should go quiet immediately. So why does something strange sometimes happen in between? Why do you occasionally hear your name called from nowhere? Or jolt awake just as you're drifting off, heart already racing before your eyes are open? The answer is that your brain doesn't shut down in a clean, orderly sequence. Before it fully disconnects, there's a border zone between waking and sleep that neuroscience calls hypnagogia. In this state, the thalamus has already locked the outer door, but the cortex inside hasn't received the signal to stop yet. Suddenly starved of real input, it starts generating its own content, random shapes, voices without sources, the feeling of movement with no movement happening. It's closer to a hallucination than a dream, though most people have no memory of it at all by morning because the recording system was already offline before any of it started. Out of this border zone comes one of the most physically jarring experiences the sleeping brain produces: the hypnic jerk. That full-body spasm, the sensation of missing a step and falling, the immediate snap back to full wakefulness. Research suggests somewhere between 60 and 70% of adults experience this regularly, with frequency increasing during periods of stress, sleep deprivation, or high caffeine intake. One of the most compelling theories about why it happens traces it back to our primate ancestors. As the muscles begin to relax during early sleep onset, one ancient part of the brain misreads the signal. It interprets the body going limp as a fall from a tree branch and fires an emergency alarm. The reflex was built for a world where sleeping in trees was the survival strategy. It simply never got the update that humans moved indoors. There's a fourth question that tends to surface when people go deep enough into this topic, and it's the most destabilizing one. Some people swear, absolutely and sincerely, that they were awake all night. They heard every hour on the clock. They felt the AC cycling on and off. They remember lying there thinking, running through worries, unable to quiet the mind. And yet EEG data from sleep studies tells a completely different story. The brain waves were clearly those of someone sleeping. The body was doing exactly what a sleeping body does. What's happening there is something researchers call paradoxical insomnia, and it reveals something important about how consciousness and memory actually work during the sleep transition. The brain doesn't go offline all at once. Sleep actually propagates through different regions in an uneven, region-by-region process, sometimes called local sleep. Some areas go dark while others stay lit, which means it's genuinely possible for the motor systems and part of the auditory cortex to still be running, while the memory encoding systems and the prefrontal cortex, the region most responsible for the sense of, I am here, I am experiencing this right now, have already shut down for the night. That small, persistent inner voice that keeps insisting I can't fall asleep can continue running in isolation, almost like a background app you forgot to close, even after the rest of the system has gone quiet. It keeps generating the feeling of wakefulness and recording it into the one fragment of memory formation still available. By morning, you wake up carrying a detailed report of a sleepless night. A report your brain wrote itself, about a night that didn't happen the way it felt like it did. And here's where someone always raises a fair counterpoint. If I can't trust my own sense of whether I was awake or asleep, what does that do to the rest of what I trust about my experience? It's a reasonable discomfort. But the answer isn't that your experience is unreliable in general, it's that sleep is one of the only states where the system responsible for monitoring experience is itself being taken offline. You can't observe your own awareness disappearing because observation requires awareness. By the time the crossing happens, the observer is already gone. What the research ultimately reveals about the nightly vanishing of that moment is not a flaw or a mystery waiting to be solved. It's the system working exactly as designed. Your brain dismantles your ability to record in a precise sequence. Sensory input closes first, memory encoding stops second, and the prefrontal sense of selfhood goes last, or in many cases first, before you even realize sleep has started. The moment you'd need to remember was never made available to the part of you that does the remembering. Every night, something that functions very much like a version of you temporarily stops existing. What wakes up in the morning isn't a continuation of the you that closed your eyes. It's a version that was rebuilt, reorganized, and in many ways strengthened during hours you will never have access to. The forgetting isn't a gap in the record, it is the record. And maybe that's not unsettling at all. Maybe it's exactly the arrangement a brain designed for survival would choose. Protect the repair process from interference, let the conscious mind dissolve completely into it, and bring back something a little more whole on the other side. Drop a comment right now with this. Do you usually fall asleep fast, or does your mind stay loud long after your body is still? Read the thread because the answers are genuinely interesting. Subscribe to this channel if this is the kind of question that pulls you in. Share this with someone who's been awake at 3 in the morning convinced they haven't slept at all. And if this shifted something in how you think about your own brain, leave a like. That's the kind of signal that lets this content keep reaching the people who actually want it.